Hi, everyone. Hope you can hear me. Yeah, so thanks for joining my talk. I'll be talking about Nomad and Flatcar, Flatcar and Nomad. So yeah, how to run Nomad on Flatcar and why you should run Nomad on Flatcar. So I got introduced already, but yeah, I'm Yago, and you can find me on social networks like GitHub or Twitter under this handle. I'm a principal software engineer manager at Microsoft, and yeah, let's just get started. So what is Flatcar? Yeah, I'm assuming no knowledge of Flatcar, or actually no knowledge of Nomad either. So yeah, let's start with what Flatcar is. So according to the Oxford Dictionary, a flat car is a car on a train without a roof or sides used for carrying goods. And this is what this arrow shows. So I didn't know about this, and I've met some people in the U.S. that didn't know about this either. But yeah, that's I think this is a pretty cool metaphor because as you will see in this talk, flat car is made for running containers, and yeah, a real flat car also runs containers. So yeah, let's now talk about what is Flatcar, the operating system. So Flatcar is a container Linux. So let's just start with what a container Linux is first. And the main point of container Linux is to simplify operational yeah, just simplify operations and for security and management at scale. So one of the things that a container Linux provides is a minimal distribution for containers. Why do you want this? Um, so the fact that the container Linux is minimal is great because it reduces your dependencies. So less space software to manage. Like yeah, I'm sure a lot of folks are familiar with some Ubuntu installations that grow and grow, and you keep adding packages. So this is gets it's kind of a pain to manage at scale. So yeah, this is a great characteristic of a container Linux. It also provides reduced surface attack area. So if there's a vulnerability in the software and you have less software, yeah, it's less likely that you have a vulnerability. Um, yeah, it it also a container Linux also has a secure immutable file system. So this means that everything in the /usr partition is read-only. That there's no package manager, there's no modification of CoreOS files after you deploy your machine. And this is great, and it can reduce your attack, your threat to security vulnerabilities like this one mentioned here, a vulnerability in runc. And I'll be showing you a bit what this is about in the next slide. But yeah, the fact that the user partition is immutable and read-only protects you from certain attacks. Yeah, next, in the definition of container Linux is that you have automated and streamlined updates. So the way this should work is that your operating system should update itself and it should be automated. So it will be easy to apply the latest security patches, and it's always great to to be up to date in software because there's always vulnerabilities coming up and getting patched up. And another characteristic of this is that you have atomic updates and rollbacks. So if an update doesn't work as you would expect, you can just roll back to the previous version. And then the last thing in this definition of container Linux is that you have declarative provisioning. So you have a declarative configuration that tells the operating system the state you want to have, and then yeah, you just deploy that, and that's the configuration you have. So you have no drift from that. And this, in a more philosophical way, goes to this immutable infrastructure paradigm. So yeah, as I said, no changes during production. Your node should stay the same from the deployment on. And yeah, this allows you to have repeatable deployments. So yeah, on that vulnerability that I just mentioned in the slide, just want to show a quick demo of how this is mitigated. So this vulnerability, what it did was take advantage of some malicious things you can do in a container to overwrite your runc binary, and then from there you can do a lot of bad stuff because you're running on the host with privileges, and you can do bad stuff for next container that start. So this is trying to do just that. And yeah, it tries to get the inode of the exe file of the pid1 of the container, which in this case is runc, but it tries to override it, and it's a read-only file system. So yeah, I think this is pretty great, and yeah, it mitigates this kind of vulnerabilities. Yeah, just a bit of context on Flatcar's heritage. So it's nothing new. So Flatcar itself is derived from CoreOS Container Linux, and I'm pretty sure most of you will remember CoreOS. And that itself was derived from two sources. So Gentoo, which is where it gets the packages, and then Chrome OS, where it gets the update mechanism. So all that combined went on to creating CoreOS Container Linux, and after that was end of life, we took it over with Flatcar. And yeah, Flatcar comes in several channels. So you have an alpha channel, a beta channel, and a stable channel. And so the alpha channel has always the latest stuff, and it's a good practice to run a couple of nodes running on the alpha channel in your cluster, so you can detect things that go wrong early, because everything that's in the alpha channel will go to the beta channel with time, and then that will go to the stable channel in the end. So yeah, it's a good practice to run a couple of alpha and beta nodes just to see what's coming and to see if it breaks your setup. We also have an LTS channel, which is long-term support. So in here, the changes are more slowly, happen more slowly. So yeah, every 6 months we have a release, and yeah, this is ideal if you want to have something very stable. Yeah, Flatcar is publicly available, so you have images on AWS, Azure, Packet, yeah, lots of clouds. You can download the images on that URL, substituting the channel to the channel you want. And yeah, there's an update server. We have our public update server where you can get the updates automatically. But if you want, we also have this software called Nebraska, which allows you to handle your updates in your own way and define, times to update and the versions that you want to update certain machines in your fleet. So yeah, how Flatcar fits Nomad nicely. So I think, yeah, both are very, big on simplicity, and this is something I really like. So I think they really fit together. With Flatcar, you kind of, forget about your OS, as I said in the last point on this slide. So it's always updated. Updates are applied automatically. You have repeatable deployments. So yeah, and Nomad is very simple, and yeah, I really like that. Yeah, one thing is that Flatcar is made for running containers, and I know Nomad runs some other workloads like Java applications. So in this case, Nomad and Flatcar only make sense if you run containers on Nomad. So yeah, I want to talk a bit about how Flatcar is configured, and so let's dig in. Yeah, so on Flatcar, as I said, you have a declarative configuration, and this is run with this software called Ignition. So the format is JSON, and in this declarative configuration, you just declare what files you want to have on your operating system, what systemd units, what networks you want, what users, file system partitions. You can, configure all that. And one thing is that it can reference data from external resources. So that's nice when you want to, download software when you set up the machine. And the interesting characteristics of Ignition is that it is supplied from initramfs. So initramfs is some environment that you have before you actually boot your operating system, and you mount your root partition. So the idea is that here you can do things like loading kernel modules, or in this case, applying declarative configuration to your machine. For example, you can format disks, or you can aggregate disks in a RAID or something like that. And the thing is that with Ignition, this only runs on first boot. So the configuration will happen on first boot, and after subsequent boots, it won't run anymore. And it is assumed that your machine is configured already. And this goes, again, with this immutable infrastructure approach that I was talking about before. This is in contrast to Cloud Init, which you might be familiar with. And Cloud Init is something that runs on every boot. and it runs after the init ramfs, so you cannot, for example, format disks with Cloud Init. So yeah, this is the difference between Cloud Init and Ignition. And since writing JSON is not really that user-friendly, I would say, we have this concept called Container Linux config, which is a friendlier version of the Ignition config using YAML, which is yeah, sometimes not great to write, but I think it's nicer than JSON. And yeah, it also adds some extras to make your life easier. Like you don't have to define permissions, you know, with in a decimal ways, which is kind of not the way you define permissions usually on Linux, and a bunch of things. So from this Container Linux config, you can run it through a transpiler and convert that to the JSON that actually will get shipped to the machine. There's a specification if you're interested in looking at this. So yeah, just as an example, you can see here on the left, on the top left, that you have a Container Linux config, which is using YAML, and here it defines etcd and some version. And then you run it through the transpiler, CT, for a particular platform, and then that generates the Ignition config for that platform. And the then result is at the bottom, and it's a systemd unit file with the etcd software configured. And yeah, this is another example where you can just add some file on etc, and you define where the file should be, the contents, and the file will end up there. So how do you install Nomad on Flatcar? This is an interesting question because it doesn't have a package manager, so you cannot just do apt install Nomad. And yeah, actually Nomad is not made for running in containers, which would be the natural way of running software on Flatcar. So there's no official container, and you probably don't want to just get a random container from the internet that says it has Nomad. And as I said, running as a container is not supported anyway. And so, yeah, we want to use this immutable infrastructure approach. And the solution that I came up with is just using Ignition to deploy the Nomad binaries onto the file system. And once that's done in the first boot, then subsequent boots will have this binary and it will just work. So this is an example of how you can accomplish that. So you can get the official zip from the HashiCorp release. And yeah, to be extra sure that you're getting what you expect, you just put the hash of that file, and Ignition will take care of verifying that this hash matches with what you download there. And if it doesn't, that file won't end up on the file system. And if it does, it will. So combining this with a systemd unit that extracts this zip binary in /opt/bin, you can get the Nomad binary where you expect to. And yeah, if the Nomad binary is already there, it won't extract it, of course. This is the condition path exists that you see at the top. And yeah, this is a nice way to have your binary deployed. And so that's pretty much it. So I was preparing this talk and I was like, oh, maybe it will be a bit hard to run Nomad on Flatcar, but it turns out it just works, which is great. And I really like that. So yeah, there's not much to it. So I want to talk a bit about what's missing in my point of view, so the integration of Nomad and Flatcar works perfectly. And yeah, the missing piece that I find is update orchestration. So yeah, ideally, you don't want your nodes to update at random times or when they feel like. You might end up with all your nodes updating at the same time, and then your application would go down. So this is not great, definitely. And you can accomplish this with Locksmith. So with Locksmith is a protocol that's used on Flatcar. So not all your updates happen at the same time. Just to show you a bit graphically, this is how it works. So it depends on etcd, on having an etcd cluster on your cluster. And yeah, the way it works is that each node checks for updates. When there's an update from the update server, it downloads a new image. It downloads that to a secondary partition. So your OS still runs and is fine and dandy. And then the locksmith service inside your node checks if there's a lock on your etcd cluster. If the lock is available, it will just reboot with the new partition. So the new partition will have the updated version. And if the lock is unavailable, then it won't do that until the lock is available. So this is how you prevent all your nodes updating at the same time. Then yeah, even better than that, it would be great to have your workloads moved to other nodes before you reboot, so you don't have service interruption in your applications. And this is what this Flatcar Linux update operator software does, or Fluo, how we call it, on Kubernetes. So yeah, the way that this works is that similar to previously, each node checks for updates, downloads a new image to the other partition, the partition B, and then it sets some annotation on Kubernetes on itself that it needs reboot, so reboot needed. And then the operator will drain that node. And once that node is drained, so no workload is running there and everything is reallocated to other nodes, it sets another annotation on the node saying, hey, you can reboot now, reboot OK. And then the agent running on the node will just send the reboot signal to the update engine service, and it will reboot in the new partition. And once the node is up, it's re-added to the cluster, and workloads can be scheduled there again. So yeah, I think it would be great to have something similar for Nomad, and this is not implemented yet, so this is a missing piece. And I think the main missing piece, really. Otherwise, things work flawlessly. So I wanted to do a quick demo of how to run Nomad on Flatcar. I have a repo there, and I have to warn you that it's pretty hacky. I just wanted to prove the concept of deploying Nomad on Flatcar. So definitely not use this for production. But yeah, I'll show you anyway, so you can see how it worked. So yeah, I have here the repo clone, and what I'm gonna do is I'm gonna show you the files that are in there. So we have several YAML files, and this is the Container Linux config that I was referring to before in the talk. And then we have a simple shell script that deploys machines, and we have a make file that can generate the actual ignition files, which are these .ign files here. So I'm going to show you a bit the a YAML file, and yeah, this actually implements this thing that I was explaining before, the prepare Nomad binary service that extracts the Nomad binary. I also installed console here, and this is the actual service that starts the Nomad agent. So yeah, as you see, nothing too shocking here. It's just a systemd unit file. And if we go to the Nomad common storage, you can see how I download the Nomad files, as I explained before in the slide, with the hash and also the console files. And so, yeah, I wanted to keep this very simple and don't use something fancy like Terraform, which you probably want to use if you want to do this in production. So I wanted to keep it simple and just have a simple script and use that to deploy it. So I organize my YAML files here by functions, and then I do a very, very embarrassing set substitution to do some templating. And in the end, you end up with a file like this. This is a final file that will get deployed to the machine. And yeah, you can not really see that, but let's do some formatting here. And this is the JSON file, the ignition JSON file. And yeah, it's another version of the YAML file that I was showing before, but in JSON format and with all the templates resolved. And yeah, after that, I have this simple script that just uses the AZ commands to deploy Azure VMs. And the interesting bit here is that when you deploy a machine, let's say here, you pass the custom data and you pass the ignition files that got generated, and then that deploys your cluster. So after running this script and deploying all the machines, you end up with a Nomad cluster. And I'll just show it here, it's currently empty, but you have your clients, you have your servers, and yeah, everything is running on Flatcar, as you can see here somewhere, maybe in the clients. Yeah, this is the kernel that the latest Flatcar stable ships. And so, yeah, just for completion, I wanted to show something working. So I had this demo web app that's in the Nomad documentation. And I don't really have much experience with Nomad, so this was a great way to start, just reading the getting started. So I'm deploying a demo web application, and then I'm deploying a traffic load balancer. And so just to show you that things work, I'll plan this again. I think I just planned the demo app. I didn't deploy it, so let me just quickly do that. And yeah, now things will hopefully be running. So I don't use any external load balancer. I just do some port forwarding to the machines to keep it simple again. And you can see the traffic dashboard here running on the cluster, and then the application should be running eventually once it converges. And yeah, hopefully soon. So eventually it would run. I don't know how I'm with time because I started early, but yeah, there you go. So yeah, and now the application started on node 07, and traffic should be load balancing to other nodes, which doesn't work yet, I guess, because the application hasn't been deployed on other nodes. But yeah, you can trust me that this works. Cool. So yeah, that was a demo, and I just wanted to add some last things on an appendix. You can check the Flatcar documentation in this URL here. And my colleague Kai has been creating some repository to deploy Flatcar with Terraform with best practices. So there's some examples on this repo. And he recently gave a talk on this topic of immutable infrastructure with Flatcar at FOSDEM, which I think it was a couple of weeks ago. So yeah, you can check that out on this link here. Yeah, I think this is all I had. I hope you enjoyed this talk, and I hope you play with Flatcar and with Nomad.